This is AQA GCSE Coordinated Science Chemistry Higher Paper 1 from June 2018, and this is question 8. And the question is about iron. Iron reacts with dilute hydrochloric acid to produce iron chloride solution and one other product. Name the other product. Now this relies on you knowing the general equations. An acid plus a metal will react to form a salt and hydrogen. And you could write the word hydrogen down and get the answer, but if you write the formula, you must show that it's diatomic. Suggest how any unreacted ion can be separated from the mixture. Whenever you're trying to remove a solid from a solution, you're going to use filtration. On to 8.3, we've got 0.12 grams of magnesium reacting with excess iron chloride solution. So we're going to start off with the equation, and we've got Mg reacting with FeCl3 to make Fe and MgCl2. Now I need to balance this, and I'm going to start with the chlorines. Lowest common denominator of 2 and 3 is 6, so I need 2 FeCl3 and 3 MgCl2. And I then need to balance the magnesiums and the ions, which I've then done. This allows me to go ahead and do the reacting masses question. I draw my table. I put the mass that I know and the mass that I want to know at the top, so that's Mg and Fe, and I complete the table with my mass, my molecular or atomic mass, in this case they're both atomic masses, my number of moles, and my ratio. At that point I can start to fill in, and I'm going to use colour coding so you can see where the numbers come from. So my mass of magnesium is 0.12 grams as provided. The atomic mass is 24, also on the periodic table, but provided within this question. To work out the number of moles, you do mass divided by atomic mass, and that takes us to 0.005 moles. Now I need the moles of iron, but I'm going to need to use the mole ratio for that. So my mole ratio is 3 to 2. 3 moles of magnesium makes 2 moles of iron, and if 3 moles make 2 moles, 0.005 makes 0.0033. I'm simply following that ratio through. Now I've also been told that the molecular or atomic mass, actually in this case of iron, is 56. And I can work out my mass by multiplying moles by atomic mass, taking me to 0.1866 grams. But we want our answer in milligrams, so we have to multiply that by 1,000, and we get 186.6 milligrams. And you can see where the marks have come from there. On to 8.4, explain which species is reduced in the reaction between magnesium and iron chloride, and you must include the half equation for the reduction. Now if I take a look at the charges, I know that the charge on an element is 0, and I know that magnesium forms ions with a charge of +2. Now if the charge has gone up, that means it has been oxidized. I can also then look at the fact that iron in this case is +3, and it goes to iron 0, so my charge has reduced. But actually if I break all of this down and take just the ions becoming iron, my half equation will look like this to begin with. I need to balance the charge. I do that by adding electrons. I'm going to add 3 electrons to the left hand side. And that actually tells us why we know the ions have been reduced. Oxidation is loss, reduction is gain of electrons. That's the oil rig mnemonic that you might remember. The Fe+3 has gained electrons. We've shown that it's reduction.